processing interrupts in 8259. Now let us see how this Intel 8259 IC is processing the interrupts. The first step which we need to do as a programmer is we need to initialize the following registers. Intel 8259 has got two control registers called as ICW and OCW. ICW stands for initialization control word. OCW is called as the operational control word. So these two registers needs to be initialized before processing any interrupt. This will be our first step. The second step will be the interrupt request from the interrupting device has to reach a register called as IRR. IRR is called as the interrupt request register, which is present in the 8259 IC. Next, the IC, after receiving an interrupt request, will try to service the interrupt. Let us take a situation where there are 8 interrupts which are connected to 8259. So in this case, the interrupts which are triggered by the external device needs to be prioritized. This is prioritized with help of a block called as the priority resolver block. This priority resolver block will check the status of IRR register, it will check the status of ISR register and then IMR register. ISR is called as the interrupt service register, which will have the status of current interrupt which is being serviced. Then IMR, which stands for interrupt mask register, will have the status of interrupt pins which are masked using software. Based on this, the priority resolver register will be able to permit the priority level of interrupt which is to be serviced. The fourth step will be 8085 microprocessor. After receiving an interrupt request from the interrupt controller, the 8085 microprocessor will be sending an interrupt acknowledge signal back to the 8259. This interrupt acknowledge signal, the active low signal from the processor, will be sent 3 times. The purpose of sending the same signal 3 times by the processor is to read the opcode of the call instruction. During the second and the third INTA pulses, the 8085 processor will be able to read the vector address of the interrupt which is being requested. So this is the purpose of INTA signal. So this signal is coming from the processor to 8259 microcontroller. Now coming to the last step, this will be the last step in processing the interrupt. Once the 8085 microprocessor has got the vector address of the interrupting device, then the interrupt program will be initiated. The processor will be executing the interrupt program which is triggered. Once the processor completes executing the interrupt program, then the processor needs to send a signal called as EOI. EOI stands for end of interrupt. This end of interrupt can be programmed. There are two types of end of interrupts which can be programmed. One is called as EOI. The second one is called as AEOI. EOI stands for end of interrupt. AEOI stands for automatic end of interrupt. So these two modes can be programmed on 8259. So how we are going to do this? We are going to learn this process in the next slide. Programming an Intel 8259. To program an Intel 8259, we have to follow a particular sequence. So that sequence is very beautifully demonstrated in this flowchart. So we start the program. The first step we will do before writing the code is initializing the control word. As I said earlier, we have two control words in 8259. One is called as ICW, second one is called as OCW. I stands for initialize. The word O stands for operation. CW stands for control word. First step in programming 8259 is sending the ICW1. 8259 has got totally 4 numbers of ICW and then 3 numbers of OCW. The 4 numbers of ICW, not all levels are mandatory. For instance, if you have a look at the flowchart, you can see there are two send signals which says send ICW1, send ICW2, meaning ICW1 and ICW2, these two control words has to be sent mandatorily before we start programming the 8259. Those are mandatory control words. ICW3 and ICW4 are optional. ICW3 will come into picture only if we are configuring the system in master slave mode. If that mode is not enabled, then ICW is not required. Then ICW4 will be transmitted from the processor only if there is a need. Okay, so we will try to understand what is the need when I disclose the format of ICW4. Once the ICW control words are transmitted from the 8085 microprocessor to 8259, the next process which will begin is sending the OCWs. We will start with OCW1 and OCW2. OCW3 will be sent based on the requirement. If there is a need, we will transmit, otherwise we will stop with OCW. So this is the sequence. So let me reiterate the flowchart which is shown here. First is the ICW1 control word is sent by the processor. Then ICW control word is sent by the processor to 8259. Then the 8085 processor checks for the mode of operation, whether the 8259 is configured for cascade mode or single mode. Okay, if it is cascade mode, then the processor needs to send ICW3. Okay, if it is single mode, this step is skipped. Okay, if it is single mode, this step is skipped, then the program will move to ICW4. So there is a decision box here which checks whether there is a need of ICW4. So ICW4 need will be checked when I send the ICW1. There is a bit which is associated with ICW1 which will say whether ICW4 is required or not. So if it is required, then ICW4 will be sent. The next step after initializing ICW, the next step will be sending OCW. There are 3 OCWs, out of which 2 OCWs can be sent. Okay, OCW is called as operational control word. The purpose of operational control word is, as you are executing ICWs, as you are initiating the programming of 8259, if you wish to change the status of some control bits, it can be done only by sending OCW. ICW, once it is sent, I cannot modify the content of ICW. Say halfway through a particular application, you require to change the control status of a particular signal. It cannot be altered by sending a signal, ICW signal. I have to send an OCW signal stating that there is a change which is happening in the system, and we can instruct 8259 to change the control bit of a particular signal. Okay, so that is the purpose of OCW. Next, we will take a very clear look into how ICWs and OCWs can be programmed. In this slide, I'll be discussing about the format of ICW. As I said earlier, ICW stands for Initialization Control Word. Okay, you can highlight the word I. I means initialization. So before I start executing a particular interrupt request, this has to be sent. The format of ICW goes like this. The first bit, which is the IC4 bit, the 0th bit of this register, it's an 8-bit register. Okay, you can see the bits which are numbered as B0, B1, B2, B3, B4, B5, B6 and B7 respectively. Okay, and there is an additional bit which is showed in this format, which is called as the A0. What is A0? A0 is the internal address of 8259. It is the internal address of 8259. Okay, When I say ICW, ICW is a single register. Okay, how then A259 will differentiate ICW1 and ICW2? So this differentiation can be made by reading the status of A naught. If A naught is written with a logic level 0, the meaning is we are going to transfer ICW1 to 259. Okay, so by reading the status of A naught, we will know whether the current data which is transmitted to 8259 is ICW1 or ICW2. Right? So that is the first signal which needs to be read by the programmer. Now we will come back to the first bit in ICW1. The first bit in ICW1 is called as IC4. So if this bit is set to 1, it means that I am going to transmit ICW4. If this bit is set to 0, then it means ICW4 is not required. So whether I am going to transmit ICW4 or not needs to be specified in the 0th bit of ICW1. Okay. Then we have the bit number 1. Bit number 1 is called as SNGL. So this will indicate the mode of operation, whether I am going to operate this IC in single mode or cascaded mode. This is based upon the requirement of the application. This needs to be set in the second bit of ICW1. Then the third bit is called as ADI. ADI stands for AD stands for address, I stands for interval. When I say interrupt, every interrupting device should have an address. Okay, the meaning of this is all the interrupts which are serviced by this 8259 IC are vectored. Now, how are we going to address the interrupts? So the interrupt levels, the spacing between level 0 and level 1 can be modified by setting this bit. So there are two options which are given to us. One is if I set this ADI bit to 1, if I set this ADI bit to 1, then the interrupt interval between level 0 and level 1 will be equivalent to 4. If I set this bit as 0, then the interrupt level between first interrupt and second interrupt will be set as 8. So what is this interrupt interval? Let us assume that the vector address of IR0, okay, it's an assumption. Let us assume that vector address of IR0 is assumed as 0000. If I am setting the ADI bit as 1, then the interrupt interval is 4. Okay, so IR0 will be 000. IR1, the vector address shall be so 000, then 0001, 0010, okay. So these four levels will be occupied by IR0. Okay, the address level for IR1 will be 010. Okay, can you understand? The interval between IR0 and IR1 is, this is the purpose of address interval bit. Okay, if I switch it as 0, if the bit is set as 0, then the interval will be 8. So this is again the choice of the user. Then the third bit is called as LTIM. It is called as the level triggered or edge triggered mode. Okay, what is the mode of operation of the interrupt? Whether the interrupt is going to be requested during the level trigger or edge trigger, what will be the mode? So that can be set by setting this bit to appropriate level. So if it is level triggered mode, then select 1. If it is edge triggered mode, select 0. Then bit B4. Bit B4 is always equivalent to, okay, here bit B4 is always equivalent to, okay. Then talking about the bits B5, B6 and B7. Okay, B5, B6, B7. These are the vector address of the subroutine which we are going to call. Okay? Whenever an interrupt request is raised, a call instruction set will be written in the program. Okay, the call instruction set will have the opcode of call and the address location from where no, we wish to start the subroutine program. Okay, the lower bits of this subroutine will be mentioned in the bits A5, A6, and A7. Okay, this will have the lower three bits of the interrupt which we are going to service. What about the remaining bits? Okay, you can see a small table here which shows the remaining bits. A5, A6, A7 are set by the ICW1 by the programmer. The remaining bits, okay, and a lower byte call address will have 8 bits. The total size of the call address will be 16 bits. Okay, we have the lower byte address and the higher byte call address. Now the remaining bits which range from 0, 1, 2, 3, 4 are vacant. No, they have to be inserted. Uh, this is inserted by the system itself. The A259 will insert these bits on its own. So you can see the bits which are inserted by the system. So IR0 is inserted with 5 zeros. IR1 is inserted with the data 00100. Then IR2 is having 01000. Fine. So these 5 bits are inserted by 8259. The remaining 3 bits 5, 6, and 7 are set by the programmer. So the programmer needs to know the code word for all the 8 pins. So that is why it is listed here. If the interval is 4, you have to check this table. If the interval is 8, you have to look for this. Moving forward to the format of ICW2. ICW2 will be the second control word which is sent by the programmer. This is a continuation of ICW1. In ICW1, we are sending the low byte address of the call instruction. Okay, the next step should be we have to send the high byte address. How to send it? That can be sent in the format of ICW. Okay, so you can send ICW first by changing the internal address. Write A0 equivalent to 1. So when you write A0 equivalent to 1, it indicates that now 8085 is going to send ICW2. The 8 bits of ICW2 register will be carrying the high byte address of the call instruction set. The call instruction set will be loading 16-bit address, out of which 8-bit is coming from ICW1 and 8-bit is coming from ICW2. So that is why ICW1 and ICW2 are two mandatory initialization registers which has to be sent by the processor to 8259. Now coming to IC3. ICW3 is an optional control word which is sent by 8085. This optional control word is sent by 8085 if we are using the system in cascaded mode. That is, if you have devices connected in master slave configuration, then this format word should be sent by 8085. Now let us have a look at this ICW3. ICW3 has got two formats. One is the format for the master device, second is the format for the slave device. If you have a look at the format for the master device, you can see there are 8 bits and each bit will be holding the data of the IR pin. Okay, if it is 1, it says the IR input has a slave. If the bit is equal to 0, it means that there is no slave device connected to that particular pin. The master device is having totally 8 pins, okay, which means I can connect 8 slave devices to this master setup. When I am executing this, I have to write A0 equal to 1. This will be the internal address of 8259. Next is the format of slave device. The master device will be sending the control signals to slave device in a particular sequence. every slave device which is connected to the master, there are about 8 slave devices which are connected to the master. So each slave device can be identified by the master using a number called as the slave ID. So every device which is connected to the master as is assigned a slave ID number. For example, the IR0 pin of master device will be connected to slave number 1. IR1 pin of the master device will be connected to slave number 2. So slave 1 will be having an address. The address of slave 1 is 000. The address of slave 2 is 001. So likewise, we will be able to connect 8 slave devices to the master. So every slave device will have a corresponding address which is shown in this table. This slave ID number will be part of the IC3W format. The first 3 bits B0, B1, B2 will be carrying the slave ID number. Then talking about bits B3, B4, B5, B6 and B7, they remain vacant. And when we are communicating ICW3, A0 should be set as 1. Next, moving on to the format of ICW4. ICW4 is again an optional format control word which can be sent by the 8085. The necessity of ICW4 can be set when we transfer ICW1. What is there in ICW4? ICW4 has got the following options. The first bit is called as mu PM. This is the microprocessor select bit. This 8259 IC can be interfaced with 8085 as well as 8086 versions of microprocessor. So this can be selected here. Okay, if I select 1, it means 8086 can be interfaced. If I select 0, it means I can interface 8085 with this system. Next is the automatic EOI mode. So AEOI mode can be selected by choosing this bit. If it is 1, then AEOI is enabled. If it is 0, then normal EOI is enabled. Then bit B2 will indicate whether it is operating in master mode or slave mode, whether the device which is communicating is operating in master mode or slave mode. The next bit is called as the buffer bit. Okay, so the bit buffer and master slave bit will operate together. So this is the sequence in which it needs to be programmed. If I am placing 0x, then the indication is non-buffered mode. If I program 10 in this position, the meaning is buffered mode slave. If I am programming 11, the meaning is buffered mode master. Okay, so this is how these bits can be programmed. Then we have the fourth bit, which is called as SFNM. When I was teaching the priority modes of 8259, the SFNM stands for specially fully nested mode. So specially fully nested mode will be activated if the device is performing in cascaded mode. Then we have the bits B5, B6, B7. These bits will be set to 0. A0 bit, the internal address of this IC, will be set to logic level 1. With this, we come to an end of the formats of initialization control word.